There's a lot of pros to lithium iron phosphate batteries out there, but there's also some cons that not a lot of people talk about. So if you're considering a lithium iron phosphate battery for your trolling motor, you're in the right place. What I have here is a LiFePO4 24 volt, 25 amp hour battery, and it will run my NK180 trolling motor for about an hour and 7 minutes at 100% full throttle. So essentially I can rock out around 6.08 miles on this battery at a 90% discharge. So we'll talk about that a little later, but a lot of punch for a very small battery. So let's talk about pro number one. Let's talk about longevity on these bad boys. One of the major differences between a lithium iron phosphate battery versus your traditional lead acid battery is longevity. The lead acid battery will typically have around 200 to 500 cycles before it needs to be replaced. Now that also depends on how deeply it's discharged, also known as the DOD or the depth of discharge. For example, the DOD rating refers to percentage of the battery's full capacity that you use each time before recharging. So a DOD of 80%, for example, means that you're using only 80% of the battery's capacity each instance before recharging. And that's why there's such a broad range of cycles, right? 200 to 500, because it depends on how much battery you discharge before every charging. Now with the lithium batteries, this is where this battery shines. I mean, like freaking shines. On the LiFePO4 battery, you will get up to 15,000 cycles at a 60% depth of discharge. That's pretty significant. So although more expensive than your standard SLA battery, the lifespan of these things are insane. You're looking at 10 years. All right, so now let's look at something that's very important to me as a kayak angler, which is weight. I have to take this kayak on and off my trailer, in and out of the water, and weight is an important factor. So I want a battery that weighs less. And this is where lithium iron phosphates also outperform your standard SLA. For example, the same power, 12 volt, and the same amp hour, 25 amp hours, for a lead acid battery is gonna run around 17 to 18 pounds. The lithium, 13 pounds. So significantly less, and it even gets better as the batteries get bigger. Now let's talk about the BMS, which I consider a pro and a con. So generally speaking, lead acid batteries don't require a battery management system or a BMS, but lithium batteries do. And they have one to protect the cells. Essentially a BMS is a monitoring system, or essentially it's like a guardian of the battery, right? A BMS has sensors, controllers, communication interfaces that regulate the parameters of this battery. It's going to regulate the voltage of the battery's current, the temperature, as well as the charging state. This system is going to make sure that your battery doesn't operate out of its safe operating limits, ensuring a long lifespan. However, SLAs are more simple, therefore less can go wrong. But when you start to add in sensors and controllers and wires and communication interfaces, which are under this piece of plastic right here, there's just more that can go wrong, right? The good news is this is IP65 rated, it's waterproof, and it's helpful. However, it can't prevent damage when immersed in water. It's really only going to prevent exposure to splashing and moisture and extreme humidity. So I believe with a BMS, we have a pro and we have a con. So take that into consideration. All right, next guys, let's talk about charging times. The beauty of lithium batteries and the reason they're so light is because these batteries have a higher density, essentially smaller size, more punch, which provides you and me with some advantages when it comes to charging. So to charge this LiFePO4 battery, it's going to take you around 5 hours for a full charge. However, if you were charging a standard lead acid battery, it could take you anywhere from 7 to 12 hours. So if you fish a lot, this might be the option for you. All right, next let's talk about the self-discharge rate. So this is the amount of energy that this battery loses simply by sitting there doing nothing. And as you can imagine, lithium outperform the standard lead acid batteries. Lithium batteries are going to have a self-discharge rate of anywhere from 1 to 3%. When your SLA batteries, it's going to have a self-discharge rate of around 5%. Those self-discharge rates are over a period of a month. But I don't know about you, it doesn't matter a whole lot for me because I fish a whole lot more often and I use these batteries nearly every single day. So we talked about the DOD earlier. However, lithium iron phosphate batteries typically have a higher allowable DOD than your traditional SLA batteries. So most of these type of batteries can safely discharge up to 80 or even 90% of their total capacity without causing significant damage to the battery. Even though it's allowable, I still wouldn't recommend it, as I believe it does degrade your battery faster when you go down past 90%. But for this LiFePO4 battery, Anytime I get down to 20% power, I usually charge mine. On the flip side, the recommendation of the depth of discharge for the lead acid batteries is around 50%, meaning you should not discharge more than half of your available battery capacity to avoid any damage or premature system degradation on an SLA battery. It's like you're purchasing a half a battery. These outperform. Also, these batteries are safer because of what they're made out of. They are more stable than your standard lead acid batteries. Also, these batteries are customizable, right? These 25 amp hour, 24 volt batteries offer flexible expansion capabilities, right? It supports connections up to 4 batteries in parallel and 2 in series, forming a 51.2 volt, 100 amp hour system. So this configuration allows for more design possibilities and really customizing your own unique battery solution depending on what you're using them for. Now let's talk about the cons, some things you don't hear a whole lot about. Everyone talks about, oh, these things are so great. But some of the cons are this, right? At lower temperatures, the performance of a LiFePO4 battery can be notably impacted, right? Cold temperatures can lead to increased internal resistance, which in turn affects the battery's ability to deliver the required power. And this could result in reduced capacity and voltage output and really limiting the overall performance of the battery. And prolonged exposure to sub-zero temperatures can even lead to irreversible damage, affecting this battery's lifespan. So not a lot of people like to talk about that, but nonetheless, a con of the lithium iron phosphate batteries. The good news, however, to mitigate that, lead-time batteries are built with a low temperature charging protection or self-heating pads to help you overcome those challenges into winter. But make sure if you're looking at a battery and you plan on using it in really cold temperatures that they have that type of technology. On the other hand of the spectrum, high temperatures can also pose a risk to these batteries. Excessive heat can accelerate the aging process of the battery, leading to a reduction in its overall lifespan. Additionally, high temperatures can induce a thermal runaway. That's a potentially hazardous condition where the battery becomes increasingly prone to overheating and potential damage. But lead-time batteries are actually designed to monitor and control the temperature of the battery, ensuring that it remains within its safe operating range. All right, now let me tell you one of the biggest cons of lithium batteries. She's out of the way, because it's this guy right here, the special charging equipment that they need. And these things, they aren't cheap, because you got to understand that lithium phosphate iron batteries have specific voltage and current requirements that differ from any other battery chemistries like lead acid batteries. And normal chargers may not provide the precise charging parameters necessary for this battery health. So although technically possible to charge this type of battery with a normal charger, I don't recommend it, right? And this is why. They have different charging profiles. And if you don't get that right, it'll degrade the battery over time. There's voltage difference on these guys, right? And if you don't get that right, you'll overcharge, leading to damage or safety hazards or overheating or fire, etc. And they got different voltage tolerances, right? If you don't get that right, it'll lead to reduced performance and shortened battery life. So don't do it. Get one of these guys right here. I'll throw a link to all this stuff in the description below, by the way. And then it brings us to the last thing, which everybody is interested in, the cost. Now, while there's a lot of upside, there is, of course, the cost, which is a pro and a con. Depends on how you think about it. If you're thinking short-term or long-term. Lithium iron phosphate batteries will run you. This lead-time 24-volt, 25 amp hour battery is $239 right now. The lead-acid battery for the same volts and power will run you about $150 for that battery. So, more expensive on the front end, but ultimately cheaper because the cost per life cycle is so much lower. All right, so let's just say you get 5,000 cycles out of this, right? The lead time, 5,000 cycles for $239 for the battery will cost you around 5 cents a cycle every time you charge. The lead acid battery at 500 cycles at $150 will cost you 30 cents a cycle. It's crazy, right? You would have to buy 10 lead acid batteries to last as long as your lithium battery would last. Over time, you'd have to spend $1,500 to get the longevity of one $239 lead time lithium phosphate iron batteries. That's just wild. All right, so there you have it. The pros and cons of lithium phosphate iron, lithium iron phosphate, whatever batteries. There you go. Now, what I do is I am going to hook this bad boy up to my NK180 motor right here on my Kayak. Pretty simple. Just hook up the wires, turn on the throttle, and the motor takes off, and this thing cruises at 4.5 miles an hour. If you want to learn about this install, I'll throw that video up right there. Thanks for watching, guys. See ya.